Good to see you again today. Whew. This is Professor Rhines on Out in the Elements, day number 3 now. I think it's something like day 10 of our e-learning with a spring break in between there. So, hey, I've got some stuff to go over with you today. I have to rectify something yesterday. While I was taping yesterday, all of a sudden my phone stopped midway through because I was out of data. Had to delete some stuff, finally got it back together, and when I came back, I accidentally, as some of you know, I switched the percentages of the land and the water on the surface of the earth around, and so luckily some of you were paying attention and caught that, and while you're practicing those circle graphs, pie charts yesterday, you did it the right way. So we're going to review that today, do that real quick. Oh hey, look, we just happen to have a board out here in the middle of nowhere. Okay, got some markers. Let's get down to business here. Hey, I appreciate you guys watching the videos. If nothing else, it's sort of entertaining, I guess. And it's a chance for me to talk to you guys a little bit as we get into the lesson. So, hey, before we get too far, let's look at what our standard is that we're going through right now. It's ESS 2-2. You can see it right there. It says describe and graph the amounts of salt and fresh water in various reservoirs. Remember yesterday we talked about reservoirs, what that is. That's anything that's holding water, from little marshes and ponds to streams, creeks, rivers, lakes, oceans. Reservoirs, to provide evidence is proof about the distribution, how it's spread out, of water on Earth. So ESS 2-2, that's what we're covering. Okay, so today we want to make sure that we're getting the stats right, and we're going to review this because you're going to need this for hopefully what I come up with tonight for you to answer just a couple of questions on an assignment tomorrow. All right, let's make two quick circle graphs so that we can show that distribution. Remember, in order to do this correctly, you have to have two things in relation to these. You need a title, so we know what the heck the graph is about, and then labels explaining it. So this one is going to be our water to land comparison, and then this one over here is going to be our salt water to fresh water ratio. Remember, that ratio is that comparison. Okay, so this is what we're going to do today. It's what we've looked at the last 3 days. It's just reviewing it again. Okay, so if you remember, water is how much of the earth, if you think about looking at a globe, is more of it green or more of it blue? Well, since they call us the blue planet, you probably guessed it, most of it is water. And so we said it's 70.8. Yesterday we said, hey, 50%, and we divide it. And if we divide it across like this, now we have 25, 25, 25, 25 to equal 100. Circle graphs always equal 100 because there's a circle is representing 100%. Well, if water is 70%, then here's 25, there's 50, here's 75. It's going to be a little less than 75, so about right here. So all of this is going to be, and now here comes our label, all of this is water. And water, we said, was 70.8 or 70.8%, right? Should look a little like that in our water to land comparison. Now let's use green for our land. This is 25%. It's a little bit more than that, so it's around what did we say, 29.2. So it's this plus down here All right, so now this will label and say land is 29 2/10. You always add the THS on the end there because we're using decimals. So water 70.8%, land 29.2% in our water to land comparison. All right, second graph. This is our ratio of water on Earth to salt water and fresh water here on Earth, that ratio. And we know that most of it is taken up in oceans. So again, if we look right here, we'll cut that in half. And if we cut the halves in halves, each of those four pieces of the pie is 25%. And for salt water, it's 97%. So it is almost 100%. It literally is about that much that isn't salt water. Okay, so all of that is salt water. The only part that isn't salt water is 2.5%. I'm going to make it red so it just stands out right there. All right, so this is fresh water. Most of it is, remember it from the last couple days, frozen, but this is fresh water. We'll call it H2O because there's two hydrogen atoms and one oxygen atom to make that molecule, and that is 2.5%, not very much at all. And then over here, this is salt water, H2O. I'll show you here in just a second. It's 97.5%. I'm trying to have it towards me because you remember the other day it was a little sloppier, but I was trying to write sideways on it. Okay, so fresh water, just a little sliver right here. I'll bring it closer so you can see it. 2.5%, 97.5% for salt water. What do our percents always equal for a circle graph? Yep, 100%. All right. Titles, labels. Titles and labels. And this is our two pie charts. It goes along with our standard that we're talking about, where we're trying to graph the amounts of salt and fresh water in various reservoirs. Reservoirs are here, water to land, big reservoirs. And then here, the differentiating between the different reservoirs of salt water and fresh water. Just a little bit of the earth is fresh water. And only 1% is actually, less than 1% is drinkable. A lot of it isn't because it's frozen or contaminated. All right, so this is it right here. We knock this out. You watch this video tomorrow, answer just a couple of questions, and then you guys get to go into the weekend and take a deep breath. All right, peace out. We love you. Take care. Bye-bye.